Hello students, welcome to this video tutorial on calculating probability, method 1. So we're going to go through a number of examples here. They're all fairly similar, but they each have their own kind of twist. All right, so let's start with example 1. There is a bag of 8 marbles. This is very important, 8 marbles in total. 2 are red and 6 are white. Okay, so let's start with the questions. Question 1, draw a diagram of this situation. Okay, so we've got a little bit of room here. So let's just draw. Okay, so let's just draw a little bag here. So we've got 8 marbles in total. Okay, so let's draw our 8 marbles. 1, 2, all right. So we got our 8 marbles. 2 are red and 6 are white. So the easiest way to represent that is we just put a little R in 2 of them, and then we leave all the others just blank, that they represent white. So we have 1, 2, 3, 4, 5, 6 that are white. Now for me, it's easy to color these in because I have access to color here. So if I just color these in like this, there we go. Okay. All right. Let's go on to question 2. List the possible outcomes if you were to put your hand in the bag and draw out or take out a marble. Okay, so what we're going to do is we're going to write all of the possible outcomes inside these brackets. And inside these brackets, this is called a sample space. Okay, so all of the outcomes in a probability experiment are called a sample space. So if we put our hand in without looking and we draw out a marble, well, the easiest way to organize it is we could draw out a red, and then we can draw out another red because we know that there are 2 red marbles in the bag. Then we could reach in and draw out a white, draw out another white, a third white, a fourth white, a fifth white, and a sixth white. So those are all of our possible outcomes. Okay, there should be 8 in total because there are 8 marbles in the bag. So let's just make sure 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is called a sample space. Okay, so let's calculate the probability of choosing a red marble. So here's how I want you to set it up. So whenever we're calculating probability, we always start with a formula, P, and then what is it that we're calculating? Well, we're calculating a red marble. So we can just put P and then the lowercase r. Okay, so we know that the theoretical probability is the number of favorable outcomes. Now in the last note, we wrote it as the number of the number of possible times that an event can occur. But we call that favorable outcomes. Okay, and then we have our fraction line over total number of outcomes. Okay, now we don't have to write this formula out every time. I just want you to write it out for the first couple times so you can memorize it. Okay, so what does that mean? Well, the question is asking us the probability of choosing a red. So we have to look in our sample space of all the times that red can occur. So we have 1 and we have 2. So it can happen 2 times. That's the total number of favorable outcomes. There are 2 times that red can occur. And over the total number of outcomes, so let's look at our sample space again. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes, so we have 2 over 8. Now, when we express a number as a fraction, we always have to ask ourselves, is it in lowest terms? So when the numbers are even numbers, it's easy to determine whether it's in lowest form or not. we know that 2/8 can be reduced to 1/4. Okay? So remember in our last note, we said that probability is always expressed as a fraction. And then I said that I want you to take it further. Okay, so 1/4. Okay, if we want to make it as a decimal, do you remember what we do? We divide the numerator by the denominator. So it's very important that you have a calculator out. So if you don't, press pause now. You can open one up online or you can get out your calculator. Okay, so you've got your calculator. So what did you get for 1 divided by 4? You got 0.25, right? And then I want you to take the answer one step further, and I want you to express it as a percent. Now, if you remember, to do that, we simply take our decimal and we multiply it by 100%, equals 25%. It has a 1/4 chance of happening, which is 25% or 0.25 as a decimal. Okay? All right. So let's go to question 4. Calculate the theoretical probability of choosing a white marble. Okay, so let's set this up. Probability of a white marble. Now we've already written the formula over here, so we don't need to write it again. Number of favorable outcomes. Okay, so if we're looking at the white marble, how many times does white show in our sample space? Well, we can also look up here, right? 6. Or we can count them here. 1, 2, 3, 4, 5, 6. Okay, so the number of favorable outcomes of choosing a white is 6. The total number of outcomes doesn't change. There's still only 8 marbles in the bag. So we have 6/8. Now 6/8 is not in its lowest terms. 6/8 can be reduced to 3/4. So it's kind of nice that in this probability unit we get to review some fraction rules as well as converting fractions to decimals and percents. Now 3/4 as a fraction can be represented as a decimal with your calculator. You can divide 3 divided by 4, or maybe you've memorized this one because it is one of the most common ones. So 0.75. And 0.75 is expressed also as a percentage of 75%. Okay? So that's example 1. Pretty simple example. They don't really get that much more complicated. Well, let's go on to example 2. Let's see if it is more complicated. Okay. Example 2. There is a bag of marbles. So again, a bag of marbles probability question. 3 yellow, 2 red, 2 green, and 1 blue. So we have a few more different colors of marbles here. So let's start with number 1. Draw a diagram of this situation. Now, I'm not always going to ask you to draw a diagram. It's just, I thought visually, since we're starting off, it's good to have a diagram to see what it is we're working with. Okay? All right, so how many marbles do we have in total? It's always good to calculate. So we have 3 plus 2 is 5, plus 2 is 7, plus 1 is 8. So again, we have the same number of marbles. So I probably didn't need to draw the bag any bigger, but if I draw it bigger, it just makes the diagram a little bit neater. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay. So let's label these now. So 1 is blue. So I'll put a B in this one. 1 is blue. 2 are green. You don't have to switch colors. You can just label them with your pencil. So 2 are green. 2 are red. Now it doesn't matter if you use capitals or lowercase letters. It really doesn't matter. And then the last 3 are yellow, which are not really going to show that well. It's very difficult for me to even see them on the page. Okay. All right, let's begin. List the possible outcomes if you were to put your hand in the bag and draw out a marble. Well, the best way is to simply look at this here, part of the question, and then just write the codes down here in our sample space. So if we have 3 yellow, we have Y, Y, and Y. And then we have 2 red, so R, R. We have 2 green, G, G, and we have 1 blue. So again, make sure you got them all. 1, 2, 3, 4, 5, 6, 7, 8. That is our sample space. Okay? So let's look at question 3. A. Are the outcomes equally likely to occur? In other words, if you put your hand in, is it equally likely to get a blue as it is to get a green, or as it is to get a red, or as it is to get a yellow? So what this question is asking is, do we have the same number of outcomes for each possible event? Well, the answer is no, because we have less blue marbles and we have more yellow marbles. So let's just here say no. Okay, let me change widths of my pen. Which outcome seems most likely to occur? Well, if we look at the bag or if we look at our list up here, the outcome that seems most likely to occur is yellow. Oops. Sorry about that. Okay, yellow. And we'll just put a little definition or explanation why. Sorry, having trouble spelling. There are more yellow marbles. Okay, all right. C, which outcome seems least likely to occur? Well, look at our bag, look at our list. What color of marble is least represented? Well, that's blue. Okay. And are there any outcomes that are equally likely to occur? In other words, are there any colors of marbles that have the same number of outcomes? Well, in fact, we do. We have red and green. They're both represented by 2 marbles, so they are equally likely to occur. So let's put red and green. Okay, does that make sense? All right, let's keep going. See if I can still keep that diagram. Yes, I can. All right, calculate the theoretical probability of pulling a yellow marble. Okay, so let's set it up with the big capital P, and in this case, a lowercase y. So remember theoretical probability, the formula is number of favorable outcomes over the total number of outcomes. Well, we know the total number of outcomes without even thinking about it is 8 because there are 8 total marbles. Okay, so we're looking at yellow here. How many favorable outcomes are there of yellow? Well, there are 3. There are 3 yellow marbles. So there are 3 possibilities that yellow can be grabbed from the bag. All right, so this fraction, 3/8, can it be reduced? Actually, no, it can't. So it's in its lowest form. So all we need is our calculator to calculate the decimal. Please calculate it. 3 divided by 8. I'll give you a second here. All right, so hopefully you got 0.375. And it's very important that, well, this number, it actually ended at the 3rd decimal. But if you get a really long decimal, go to the 3rd decimal place, tenths, hundredths, thousandths, and don't round. Just leave that number. Because when we go to calculate percentage, that will give us 1 decimal place of percent here. Okay, 1 decimal place of percent. So hopefully you got 0.375 and 37.5%. So why don't I give you a minute head start to calculate the last question, and then hopefully by the time I start, you will have an answer or close to an answer. Okay, why don't you start now? Okay, I'm back. So probability of a blue marble equals 1 over 8, because there's only one blue marble in the bag. 1 over 8, 1 divided by 8 equals 0.125 equals 12.5%. So hopefully you got that answer as well. Okay, so let's go on to example 3, another marbles in the bag example. All right, there is a bag with 9 red marbles, 2 blue, and 3 green in it. Number 1, calculate the probability of randomly selecting a non-blue marble. Okay, so something a little bit different here. So, probability of non-blue. Okay, well, let's set this up. The first thing you always should calculate, you should always be mentally calculating that even before, even as you're writing the formula out, is what is the denominator going to be? The denominator is the total number of outcomes. So we have 9 plus 2, which is 11, plus 3, which is 14. Kind of an unusual denominator, but totally okay. Okay, so let's think about this. Non-blue. Okay, so non-blue. So we know that there are 2 blue marbles, so we don't even look at this because it has to be non-blue. So non-blue means 9 and 3. The 9 red marbles and the 3 green marbles. Well, if we were to add 9 plus 3, that would give us 12. Oops. Okay, so all the marbles that aren't blue are the 9 red marbles plus the 3 green marbles. That equals 12. Now 12 over 14, they're both even numbers. So we know that that's not in its lowest form. So if we divide both by 2, we get 6 over 7. Okay. Then if we use our calculator, 6 divided by 7. We get our first example of kind of a messy decimal answer. Well, when you get a messy decimal answer, then I only want you to go to the 3rd decimal place, to the thousands place. No rounding, just cut the rest of the number off. Did you get 0.857? And then if we multiply 0.857 times 100%, we get 85.7. And when we change it to percent, we end up with 1 decimal place. Okay, and that makes sense because we take this number and we move the decimal place 2 places to the right. So hopefully you got 85.7%. Okay, let's go on to example 2. Calculate the probability of selecting a red marble. Okay, so this is kind of more of a traditional question here. Probability of red. So why don't I give you a minute to come up with the answer, and then you can check it with my answer. All right, so hopefully you got the starting fraction of 9 over 14. The denominator doesn't change. There's still only 14 marbles in the bag, and we have a total possibility of getting 9 red marbles. 9 over 14 with your calculator is 0.642. Again, we cut that ugly decimal off at the 3rd decimal point, and then when we multiply it by 100%, hopefully you got 64.2%. All right, last example. And this example does not involve marbles in a bag. All right, example 4. If a number is randomly chosen from the following list, this list down here, what is the probability that the number is a multiple of 5? So let's look at all the numbers in the sample space. 32, 49, 55, 30, 56, 28, 50, 40, 45, 43, and 25. It's okay that there are two number 40s. That's fine because in previous examples, there were 2 blue marbles or 3 green marbles. Okay, so this is the part of the question you need to understand. What does a multiple of 5 mean? Well, we know that multiple simply means 5 times whatever number. So can that number be divided by 5? So if we were to start a set here, okay, we know that these are the first few multiples of 5, and so on and so on and so on. So let's look at our list here. Is 32 a multiple of 5? No. Is 49 a multiple of 5? No. Is 55 a multiple of 5? Yes, it is. Is 30? Yes, it is. So in other words, if the number ends in 0 or 5, it is a multiple of 5. Is 56? No. 28? No. Is 50? Yes. Is 40? Yes. So if you don't have a highlighter, you can just circle these or put a check mark above them, whatever system works. 45 is, 40 is, 3 is not, 25 is. Okay? So how many do we have here? We have 1, 2, 3, 4, 5, 6, 7. All right, so let's work this out. Probability of, and this is where sometimes you see some long things in brackets here. So we got to write this out. Multiple of 5s. Probability of multiple of 5s. Now, I already calculated it out and I already forgot. So how many was it? 1, 2, 3, 4, 5, 6, 7. Okay, so we have 7 possible numbers that are multiples of 5. And then what is the total number of outcomes? In other words, what is the total number of numbers in our sample space? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 7 over 12, unusual fraction. Can it be reduced any further? No. So, taking your calculator, could you calculate the decimal? Probably going to be a little messy. I got 0.583. Again, stop at the third decimal place, okay, in the thousands column. Then, when we multiply it by 100%, we should get 58.3%. So in this sample space of numbers, 58.3% of them we would have a probability of getting a multiple of 5. Okay, so we've gone through 4 different examples on how to calculate probability. Thanks for watching. Bye.